Chapter 3, Chemical Equilibrium, Class Life Science. Part 3, Reversible Reaction. At the end of this session, students should be able to define a reversible reaction, specify the characteristics of the reversible reaction. C1 definition. What is meant by reversible reaction? The general equation of the esterification reaction is RCOOH plus R prime OH give RCOO R prime plus H2O, carboxylic acid plus alcohol give ester plus water, and the general equation of the hydrolysis of an ester is ester RCOO prime RCOO R prime plus water H2O give RCOOH carboxylic acid plus R prime OH alcohol. What do we conclude? The products of the esterification reaction, which are the ester and water, are the reactants of the hydrolysis reaction. These two reactions can be represented by the same equation, RCOOH plus R prime OH give RCOO R prime plus H2O, and in the other direction, RCOO R prime plus H2O give R prime OH plus RCOH. Then this equation represents two reactions. We have two directions. The forward direction is the esterification reaction between carboxylic and alcohol give ester plus water, and the backward or reverse reaction is the hydrolysis of ester, reaction between ester and water to give carboxylic acid and alcohol. Then the esterification is the forward reaction and the hydrolysis is the backward one. Such a reaction is called reversible reaction. Then, what is meant by reversible reaction? Reversible reaction is a reaction that takes place in two directions simultaneously, that means at the same time. Forward, what are these two directions? The forward direction, reactants are transformed into products, and the backward or reverse direction, the products are transformed into reactants. Now, what are the properties or the characteristics of reversible reactions? The reversible reaction is partial. That means does not go to complete. That means it is not a complete reaction. It is an incomplete reaction. During reversible reaction, limiting reactant does not react completely. Then the reversible reaction is not a complete reaction, because in case of complete reaction, the limiting reactant should react completely. In case of reversible reaction, the limiting reactant does not react completely. The name of the reversible reaction is that of the forward one. For example, the reaction carboxylic acid plus alcohol give ester plus water. In this equation, we have two reactions, but this reaction is called esterification reaction. Why? Because the forward reaction is called esterification. Then the name of the reversible reaction is the same as the name of the forward reaction. If we write the equation inversely, if we write ester plus water give carboxylic acid plus alcohol, this also is a reversible reaction formed of two reactions. The forward is hydrolysis. The backward is esterification. Then the name of this reaction is the same as the forward is hydrolysis. In this case, the forward is esterification, the backward is hydrolysis. Then the name of this reaction is esterification as the name of the forward reaction. The properties of the reversible reaction are those of the forward one. For example, the reaction of synthesis of ammonia from N2 and H2 is exothermic, delta H negative, while the reaction of decomposition of ammonia is endothermic, delta H is positive. These two reactions can be represented by the same equation, N2 plus CH2 give to an HC. This is a reversible reaction. This reaction is considered as exothermic because the forward one is exothermic. Then the characteristics of the reaction are the same as the forward reaction. Conclusion: comparison between complete reaction and reversible reaction. The complete reaction represented by one arrow, reactant give product. The reversible is represented by two arrows, reactant give product, then product give reactant at the same time. In complete, we have one-way direction. In incomplete reversible, we have two-way directions, the forward direction and that reactant give product, and the backward direction, product give reactants. The complete reaction is represented by one arrow. The incomplete reaction or reversible is represented by double arrow. Limiting reactant disappears completely at the end in case of complete reaction, while in case of reversible reaction, limiting reactant does not disappear completely at the end. This is the end of part 3, reversible reaction.